Welcome. Today we'll be learning how to use GitHub and Git. This is the video that you've been waiting for. We'll actually get our hands into GitHub and Git. We'll take a very simple example, and through that example, we'll already start to see how useful GitHub and Git can be when you're coding. Um, this is going to be very simple, but you'll as I said, you'll start to appreciate and see why we need or why where GitHub can help you when you're coding, right? So in GitHub, like if you've signed into your account, you might see something like this. You might not have any repositories. So in GitHub, you have this thing called a repository, right? So what is a repository? A repository is basically a project. For each project, you'll be having one repository, right? Um, you can think of repositories sort of like folders. Whatever, yeah, in your Windows or Ubuntu, if you have folders, you can think of repositories sort of like a folder. So you can have subfolders in repositories. For example, if I open this repository, I have different folders in this repository. Like I have a folder for machine learning, Jupyter notebooks, and in this I have different folders. So it's basically like you can think of it like your folders. And as such, you whatever you can do in your folder, you can also do in a repository. Like you can add new files, you can delete existing files, and so on. Without getting too much into the details of all the functionalities that you can have in a repository, let's just think of it like a project and a folder for now. Okay. So whenever you have a new idea or you need to get started on a new project, what you can do is you can go here, create new repository. Okay, for this we'll be calling this EWIT demo repository. Um, Demo for the EWIT program. Yeah, some EWIT GitHub uh, tutorial, something like that. And you can choose if you have a you can choose either to make it as public or private. Private, well, we'll talk about this. You probably won't have this option right off the bat unless you've chosen to pay for it. But anyway, just choose public. You can initialize it with a README. We'll talk about what this is later, but just click on that. It'll make things easier. Yeah, click on that and then click on create repository, and you have your repository, right? So once you have your repository, what you can do is you can actually do all your coding here itself, right? You can create a new file. Maybe you want to create a very simple uh, C program, right? So we can do that, include something like that. So we can just say hello world. Oh, oops, Control S. So you can't press Control S here. Every time you create a new file or you edit something directly on your GitHub account, you'll have to create something called a commit. Commit is basically you're storing all of the changes that you made and you're giving the change a name. You're giving it a heading and an optional extended description. So you can say created simple hello world program, and optionally you can add a, like if you want to write more about it, you can add that here. Commit directly to master branch. Don't worry about what this is as of now. Just yeah, go with this one and commit new file. What this will do is now you'll have your hello C in your uh, repository in your project, EWIT demo repository. So if you go on that, go click on that, you'll be able to see that we have this file. But this is like, you might think, oh, do I have to work on on the web browser always. What if I have to compile my program, right? That's something that we do. So to do that, that is why we've installed Git Kraken. So what Git Kraken will allow you to do is to clone a repository. So you have this option here to download or clone. So cloning a repository is basically making an exact copy of your repository on your computer, right? So that's what cloning means. You're like creating an exact copy of your repository on your computer. So let's do that. If you have signed into your Git Kraken uh, software using your GitHub account, you'll be able to if you click there, you'll be able to see an option called clone, and in that you'll be having github.com. You can go select your repository. Should be having EWIT demo, right? So you'll see all your repositories here. You can select the one that you want and clone the repo. So it'll ask you where to clone it. I mean, if you're able to see that there, so we can open the repo like so. So it'll actually be cloned. You'll be able to see where it'll be cloned. Let me just do that. Like let's just try to do it again. I won't actually do it. I have a repository for our CG lab, so you'll see the full path where you're cloning it, and Windows you'll have some other path. So you can change the path. You can clone it to whichever folder you want. In our case, it's home/someone. Someone is my username, so it'll be here. If you see, it is actually being cloned. EWIT demo, and we have the hello and the README file. Yeah, so that's what cloning is. You'll get that file, whatever is there, into your computer. Now we can actually do the compilation. So like um, cc hello world hello.c, right? Dot slash yeah. So it's working. And well, normally we don't actually commit this a.out file, but maybe you'd want to upload that a.out file to your repository. I don't know for what reason you do that, but yeah, let's just say that you do, or maybe you create a new file here. Let's do that. So let's create a new uh, file. uh, let's create a new C program file. What simple C, and here again name blah blah and return 0. So okay, we've created this file in our computer. On our computer, we have created this file. But if you go to your repository, you'll see that you don't have the a.out file, and like neither do you have the a.out file, nor do you have the newly created simple.c file, right? So what if you want to push all those files? What if you want to have all those files even in your GitHub repository? And that's naturally you'd want to do that, right? You'd want to keep it in sync. So if you go to your Git Kraken application, you'll see something like this on top, right? This will give you a list of commits that you have made. Commits are basically, as I told you, every time you modify something, if you want to uh, add it to your project, you would create a commit. Commit pretty much consists of three things: the changes that you've made, the name, and the optional extended description. So here you can, if you click on this, it'll show us whatever changes we have made. Like at the top, it's showing you that you have plus two files, right? So if you click on it, it'll give you more details here. You can see that this has been added, like this plus symbol tells you that it's been added, a new file. So we've added two new files. You can stage the changes, meaning you're adding the particular change, to this particular commit. So when you create a commit like simple.c, so when you create a commit, it'll add all of the staged files into your repository. So basically, you're telling which files to add in this commit, and you're giving a commit name, right? So if you commit it, you'll see that okay, it's been converted into a commit now. Whenever you change something, you'll have to commit it in order to actually add it to your project. You can think of it like that, right? But still, if you go here, you will observe that it's still the same, right? So what you can do is you can push the changes. So if you click on push, it'll uh, it'll push all of the changes that's been made on your computer to your GitHub account. So if you click on it now, you'll see that oh yeah, it's been synced. I've We have the simple.c here, and we have the a.out. If you click on the a.out, I think you'll you'll get some weird output because it's okay, fine. So anyway, you have three commits. The new commit that you've added, that's also visible here. So one of the useful things is that one of the useful things in GitHub is you can sync your code online. So suppose you delete your ewit.demo by accident, or like maybe you have a virus on your computer, you have to reset your computer, everything gets deleted, but your code is still on your GitHub repository. You can always download it or clone it, and you'll get it back to the state where you'd left it, where you're left off when you pushed. I mean, pushed before. So one of the uses is that you can sync your code with GitHub service, and it's like a cloud space for your uh, code, right? Um, so just hang on. So what you can use this for is okay. I have a repository for our CG lab, for example. If you go to my repositories, I have a repository for our CG lab. Whenever I create some program in our CG lab, I actually push it to this GitHub repository. Uh, you can actually see the first program here. What this will allow me to do is that I can actually clone this repository on uh, my desktop wherever I want to work. For example, let's do that now. You'll see how GitHub can be useful. So I can clone the repository, and I can open the repository. Like if I go to my uh, home, it'll actually be here now. So CG Lab, right? So maybe I'll decide to work on the second program, right? So maybe I want to work on the second program here. I'll say 2.c. Of course, I won't actually write the program here, include stdio.h. Let's just add you know, some skeleton code. So let's just assume that I have this code. I've added the code for the second program. Maybe I'll write the second program later. And I want it to be in sync. So when I go to my CG lab, I don't recommend doing this, but maybe you can sync your repository and execute your programs, right? So how would we go about doing that? You can see that oh boy, okay. So you can see that I have the unstaged file here. I can stage all the changes, and I can be like added second program. Right. So I can commit that, and then I can push. So if I check my CG lab repository now, I'll see that I have this program here. one more use case is that, okay, let's say you actually go to lab and you type in all the programs, you clone the repository there and you upload your code there. Now how would you, let's create a new file just to, or let's not create a new file, let's edit an existing file. So tomorrow if I go to lab and if I actually add the code here, I can actually edit any file I want on GitHub itself. Printf graphics, something like this. Oops, Control S. So uh, added really complicated graphics program. Right. So you can imagine adding the actual program there in your lab. So instead of this, you'd actually have your whole program. But if you go to your But if you come back home and if you check your CG Lab repository, you won't have the changes present. I don't have that graphics thingy present, right? So because you've cloned your repository and you have the repository on your computer, you can do something very simple. See, if you look at the repository, you'll see that your local master is at this commit, and your origin master is at this commit. So local master, what it means is that it is the thing with respect to your computer, the branch with respect to your computer. You don't have to worry about what master means, you don't have to worry about what branch means. Basically what it'll tell you is how far uh, your local copy, that is the copy on your repository, at which commit are you at currently. You're at this added second program, not really commit. But your origin master is where you actually create, like pull this, clone this repository from. And our origin is from this GitHub account, right? This is where we cloned our repository. So it's telling you that your origin is actually, it has one more commit ahead of you. It's so you have it has some changes that's not currently in your computer. If it's something like this, what you can do is you can pull. So if you click on pull, it'll automatically sync your local copy with whatever changes has been made. So if you look at your 2.c file, you'll see that, oh yeah, we have the changed stuff now. So in this way, you can work on your code anywhere. Suppose you get a little, like some 30 minutes free time, you can go to your library, you can open up your GitHub repository, you can work on your code there. And then once you come back home, if you want to compile your code, you can just pull pull from your repository. Pull is just like syncing your local copy with the GitHub account, right? So that's pretty much the basics of GitHub, and already you can start to see how this can be used, right? Uh, you can work on you can sync your code online. You can work on the code wherever you want, and it'll all be available wherever you go. So you don't actually have to carry your code on your pen drive or CD or something like that. I don't suppose anyone uses CDs anymore, but still, you don't have to carry your code. It's all available online. Anywhere you have an internet connection, you can start working on your code. And once you come back home, you can seamlessly, like just with a click of a button, everything will be synced, right? I hope you guys found that useful. I would recommend creating your own repository and trying out all of these things that we just learned, right? Thank you.